A count control loop runs for a specific number of times, or what are called iterations, where we go from the beginning of the loop through the loop body to the next test of the relational expression. So for example, you might ask a question like, if I put $5,000 in a savings account at 2% interest, how much money would I have after 10 years? And in fact, that's one of the questions we're going to ask in just a moment. That would be a count control loop because we're going to run the loop 10 times. And the count will determine when the loop stops. So let's go ahead and write that program. What I want to do first is write a couple of comments to talk about it. So we're going to have an initial balance, a rate of interest, and the number of years we want to run the balance for. So we'll begin by first creating these variables. So we're going to say double balance, and we'll set it to an initial value, or we could prompt the user for this, but I'll save a little time and trouble by just using direct assignment for these. We're going to look at user input in loops in the next lesson. Then we're going to say double rate equals 1.02. We'll say we're getting 2% interest per year. It's a fairly basic savings account type interest. And then we're going to say int year equals 1. So we'll start out at year 1. We'll compute the interest and the new balance for 1 year. Then we'll have the loop run again, and we'll do that for 10 years. So we're going to say while year less than equal to 10, the balance is equal to the balance times the rate. We could have also written this balance times equal rate. I'll start using the compound assignment operators more often to make the code a little more simple, at least as far as how long it is. And then year, oh, we just have to increment years, so we'll just say plus plus year. And then we'll close the loop. Then we'll have a little output statement. After 10 years, the balance is balance. And this to be grammatically correct, I'll add a little period at the end. Okay, so let's review the code before we run the program. And I want to talk a little bit about the steps that go into designing and writing a loop. The first step is always to create what I like to call a loop control variable. In this case, it's going to be years. In a count controlled loop, the loop control variable is what we're using to keep track of the count. So year is our loop control variable, and we'll set it to 1. So the first step is to create and assign a loop control variable, or declare and initialize a loop control variable. The next step, step 2, is to test that loop control variable. And that's what we're doing when we look at year less than or equal to 10. That's our relational expression, and that's the test that we make. The third step would be whatever it is you're trying to accomplish with your loop. In this case, we're trying to figure out what the balance of this account is going to be after 10 years. So we add the interest into the balance to get a new balance every time through the loop. So the third step is somewhat nebulous. It's just whatever it is the loop has to do, or what it is you're trying to get done with the loop or get accomplished. The last step is to modify the loop control variable so that the loop will eventually become false. When a loop control variable is never changed, then you have what's called an infinite loop, where the loop just runs forever. Because if we set year equal to 1 without this statement, then after we compute the balance, it's going to go back and test again. Year is still 1, 1 is less than or equal to 10, so we're just going to go right back into the loop body, and we're going to do it over and over and over again until we run out of memory, which nowadays, that's a long time. So this last step is very, very important, because you've got to make the loop stop at some point. And you need some statement inside the loop body that's going to make that happen. Now what we might do, we might add one statement in here so that we can look at what's going on from year to year. System out, print line, after year, the balance is, close quote, balance, semicolon. Okay, so what's going to happen is, while year is less than or equal to 10, we're going to compute a new balance and then display it, increment years, so that when year becomes 11, the loop will stop. Let's run the program and see what we get. So we'll save it. Java C cap 9 part2.java. Java cap 9 part 2. And so there we go. We didn't actually need that last system out since we display it twice, but that's okay. That's not a big deal. So you see how the balance changes every year. Again, the only thing I might add to this program is a number formatter so we don't have this long fractional part of this balance. But again, that's not stopping the program in any way or making the program not work correctly. And this will make the output look a little better. And to be quite honest, I'm much more interested in the processes that we go through here than how our output looks, as long as we compute the right answer using the right process in the right way. Okay, so let's go back and look again at what we did. We set up a loop control variable. We tested it so that it is true as we go into the loop. If it's not true when we go into the loop, then it's not going to go into the loop and we won't get any output and we won't get any results at all. So the loop control variable needs to be true, at least initially going into the loop. Then we perform the processing that we want, in this case, to compute a new balance. And then finally, we modify the loop control variable so that it will eventually become false. So that's how a count control loop works. In the next lesson, we're going to talk about a different type of loop, what's called a condition control loop. In the exercises at the end of this chapter, we'll have an opportunity to write another count control loop. But I want to move on to the next lesson, and that's on condition controlled loops.